Okay, so now let's see one simple comparison with Spark native code and Mapreduce code. So the very famous, the big data examples is the word count, right? So just to achieve the word count algorithm in your Mapreduce, we have to write a mapper class and a reducer class and then a driver class and compile them and then prepare a jar and run it on the cluster, right? So for showing you this example, so I have set it up these things on my Cloudera Quick Start VM. So I have this VM. I will guide you through the setup of these VMs and everything from next coming sessions onwards. Okay. So for today's session, just observe the differences, the comparison between Mapreduce job executions and all those things. Anyway, I will guide you through setup of your Quick Start VM or VMware or VirtualBox or these things. If any one of you are already not having. So most of you might be already knowing all these things, but I will still give you a 5 minutes overview on that, okay? Sometime later. So, we need to write a mapper class. So we have a few lines of code here, and we need to write a reducer class for the same thing. Something happened to this. Something wrong with it. Okay. Anyway, that's not an issue. So here is my reducer logic code and word count. Okay. This is my reducer and this is my driver program. Okay. So almost I need to write around 60 to 70 lines of code. And I need to write them, the classes, and compile them and build a jar file and then run it as a Mapreduce job. Okay. Let me see. So I already compiled that and prepared a jar file out of it. So I hope everyone is comfortable with that. The Mapreduce jar preparations and all. So that's why I'm not showing you all those things. So I can run this job. Okay. Let me take it. I'll stop my Spark shell. So this is my Hadoop Mapreduce job. So I prepared the jar mr_wc.jar file in my home directory. I'm running that as a word count, and we can see the results here. Yeah, let's see, let's wait until it gets completed.
Shiva?
Yes, Mamta.
How do we do the logging or debugging here? And do we have the option?
In Mapreduce?
Yeah, I mean, sorry, in the map or in Spark.
Spark, we'll see them, okay? We'll see how to debug. There, like you have seen, I have told you some debugging commands in Pig, right? Similarly, you have some debugging commands in even.
I don't remember the debugging things. Yeah, okay.
Oh, okay.
Because in the real time, that's more important, debugging
Yes,
and log, right?
yes, we will see that. We can do that. There are debugging commands available at each stage of your Spark program. Okay. So almost like so 12:16 it started, and 12:56 it ended, and so it's, I can say it like yeah, all other timings, like before even submitting to the yarn and all these things. So if we take another few seconds, so it's almost like 40 to 45 seconds. Okay, so it ran successfully, and let's see. So this is a simple file here, simple small file processed for word count, simple readme dot contents. Let me, sorry, could have taken the path here. Okay. So here you can see the word count of those readme.file and readme.md file. So that I have given. Let's not worry about all these results. I'm just concerned. I just wanted to give you the how concise our code will be and how much faster. So the performance differences and the easiness of development. Okay. So here we had to write 3 programs and compile them and build a jar, and using that jar I need to run it on the HDFS file and then store the results there and see. I've seen that. Okay. Now the same functionality if I have to achieve in Spark, let's not worry about, don't worry about the methods at this moment. Anyway, I will bifurcate all these things, and I will explain you all these things one by one. So during your Spark sessions, okay? So before even that, we'll try to complete these things in Scala first. We'll learn the Scala language, and then we'll go to that level. So I just have only one line of Spark code. This is just one single line of Spark code. So the same file, the same readme.md file that I gave into the Mapreduce, the same file I'm giving here. Okay. Okay. And let me take this and execute this from my Spark shell. Okay. First, let me get started into the Spark shell. So first of all, you don't have any shell feature for your Mapreduce at all. Okay. So you have to write it as an application, build a jar. That's the only way you can run. So with your Spark, you can run both as a jar. You can write an application and you can build it as a jar, and you can copy that jar to any place. You can do that. And before even doing that, if you want to test any of these things from your shell, so you can run them from the shell itself. Okay. So once the shell gets started, here you can see these things. So my current latest Spark release is 1.6.1. Okay, using Scala version of 2.10.5, and it requires the underlying Java as 1.7. So this is my Spark shell. I can run the same one-liner code. So this is going to read the same HDFS file, readme.md file, and print these results there. Let's see. So just now submitted it. You can see it took just 2 seconds, 2.6 seconds, and it printed the same word count results there. Okay, so I leave these results to be verified for your end. I trust on this. Okay, so how simple your Spark code is. It's just the same one line of code getting completed in 2 seconds. Since this is a very small file, you don't see much number of times is not so big. If you run the same thing almost like an 1 GB file, or at least to take 100 MB file and then run the same Mapreduce program and see the performance differences between how many seconds or minutes your Mapreduce program is taking and then how many seconds your Spark job is taking. Okay, so I'm giving you these programs here. Since I took only around 1 KB or 2 KB file, you don't see, but still there is a 45 seconds for Mapreduce, just 2 seconds for 2 seconds for your Spark, and around 70 to 80 lines of Mapreduce code and just 1 line of Spark code.
Shiva, where is this input file? Is in HDFS or in the local?
You can. I mean, I'm not giving you the, this current file is in HDFS, readme.md, but I want you to try with on prepare the 100 MB file, text file, upload it into HDFS, run it there, both with the Mapreduce jar and as well as your Spark shell, and let me know your statistics. Okay, I'm giving you this word count program in the today's files, and Spark code is anyway there in the it's 1 line. You can refer either from the slide, or it can refer from the video as well, or you can type the command. Okay, so don't worry about this explanation of these codes right now. We'll anyway go through these things slowly. Okay. So when I ran it sometime yesterday, so it took almost like 52 seconds of execution time, whereas my Spark took only 2 seconds of time. Okay. And so these are few other points that you can compare. Spark code is very concise, and MR code is high in code base size. Spark has supports for shells execution as well. I mean, executing your Spark commands within a shell, whereas there is no shell support present for Mapreduce. And easy to test Spark applications in shell itself. Need to develop a jar every time and submit on the cluster. Low latency results that we have seen, results coming in just 2 seconds, whereas Mapreduce is taking around 50 seconds. And development efforts also will be very less because of rich set of APIs. See, writing 1 line of code, it will not take more than 1 minute or 2 minutes of time. It's just, you should be strong enough in that skills. That's it. A developer should be strong enough in knowing the APIs. That's it. Your development effort will not take much time. And just 1 line of code. Whereas in Mapreduce, if you have to write, you need to write 3 components and compile them and build jar and all these things. It at least need an hour time. Yeah.
Shiva.
Yes.
Shiva, but in real life, we don't write Mapreduce code at all, right?
In real life, we don't.
We don't write the Mapreduce code.
Why? Why we don't write? Because we
See,
have
I mean,
advanced.
it is usually handled by either Flume or Impala or Hive. They do that, right?
Yep. So all your SQL, anything that you can achieve through SQL commands, you can achieve it with that, right? So as I told you some limitations for SQL skills, right? SQL commands, for loops, these things cannot be achieved.
Correct, correct.
So that time you have to go for Mapreduce. The same thing if you go with Spark Native, it will be even more faster. That is what I'm trying to convince here.
And how about the compatibility with the previous versions? Because we had some
Previous
issues.
versions of what?
Whatever, like you get now and then the latest versions, right? With Spark, whatever.
It's just the API getting changed. I always see there will be always a support for if you are going to new versions, there will be new APIs coming on. Okay, so you can start leveraging them. So they will still be supporting the older version APIs up to some releases. Okay. So this is something like in open source or in any fast changing frameworks, it's the same thing. Like, so what it's the same scenario from MR1 to MR2 migration, right?
Yeah, they had so many issues. That's where I'm asking this question.
So it's not, I mean, it's not that much issues or something that we faced ever in Spark releases. It's always that new features will come on, and it's you can keep on changing, upgrading. And here maintenance of your code is very easy, right? When you are writing 100 lines of code, if something changed, you need to change 100 lines of code, correct? If it is just one line of code, even if the API changed, just one place you need to change, correct? Relatively, even if it is keep on changing, you keep on releasing the new releases, here maintaining your code in Spark is much less cost effective than Mapreduce, right? What if something new features coming Mapreduce, if you need to change new APIs, if you want to change, right? Meaning you don't say that Mapreduce is already stable, it can solve everything. Meaning if there is no improvement means sometimes it gets older and no one will use it. That's already happening right now. Anything that is improving every release, anything that is changing every release, I mean changing in a sense, not improving, I can say, like improving is the right word, it will sustain for longer periods, correct? And we always should be adaptable and leave some space to accept the new improvements. Okay, that's, I don't think that as a, I mean,
No. New improvement is okay when you don't have the compatibility.
Compatibility issues, I mean, version to version, you have to be careful in selecting the underlying Hadoop versions. You don't need to, you'll not really face that much issues, I'm saying, like with my practical skills, experience. Okay? Agree?
Yeah. And
see, compatibility is not something, I mean, that you see with just with Spark or something, right? It's there with every tools, with version compatibility. We have to be careful. There will be, in any tool, there will be new changes coming in, and sometimes they deprecate some methods, and sometimes they add new things. It's the same thing, not something that Spark you will face a lot of compatibility issues.